This one's an exponential equation.
Okay.
So we got an exponential equation, and we're going to end up using some logs here.
Okay.
So we're taking a look at this, and I thought your very first instinct using a log, and you tried to use the same base because you had this scenario, log base a of a is equal to 1. I noticed that you put both to log base 7. So you put this side to log base 7, the argument then being 3 times 2 to the power of 3x minus 1 is equal to log base 7 of argument 7 and then x plus 2.
So that's allowed?
Of course, yeah. You can choose any base. Just like you can multiply an equation by a value, you choose the value. You just got to make sure you do it to both sides.
Okay.
So we took log base 7 of both sides in this case. You then used an exponential rule to make this a coefficient, which worked out really nicely. So on our right-hand side, we had x plus 2 times log base 7 of 7, which according to this rule that's just going to be a 1. We'll just be left with x plus 2. And then here, you notice that this was multiplied, so you split it. You had log base 7, argument 3, plus log base 7, and the argument is 2 to the power of 3x minus 1. Well, this ends up being a very similar scenario to that, where you can bring it down as a coefficient. So we still had our log 7, 3, plus the coefficient 3x minus 1, times log base 7 of 2 is equal to, this one is just the 1, so x plus 2. Pretty sure he's crawling in here. No?
In here?
Oh, I heard him.
Yes, he is.
I knew I saw you. Okay, so when we get to this point here, we have two x's, and they're on different sides of an equation.
Yeah.
We want to get like terms together. This log 7(2) is an actual value. We can plug this in. It's probably some decimal number. It's not wonderful to work with, but it is a number. So I could arguably distribute it. I could distribute it to both of these.
Okay, yes.
This is technically a constant. 2 is technically a constant. Maybe I should do colors here. So that's a constant. That's a constant. That's a constant. This is a constant. And then the yellow will be our variables. Eventually what we want to do is get all our constants to one side. So I'm going to keep the log base 7, 3 here. I'm going to bring over 2, which becomes a negative. We're going to distribute this part. So it will be 3x times log 7 argument 2 minus, sorry, that should be a plus there, and then minus, and when I multiply log base 7 argument 2 times 1, it just stays as is. So log base 7 argument 2 is equal to, and I already brought the 2 over from this side, so we're going to be left with just the x. So we still look again, variable, variable, everything else is constants. I could plug them into the calculator. I'm just leaving them as is, as if I'm like moving blocks around a page. That's essentially what it is. I need this to be on the other side so that my x's are together. So we leave our stuff in red here, log 7, 3 minus 2 minus log 7, 2. Okay, and actually we can do a little bit of, I'm going to redo part of that there I saw just now. I'm going to move these side by side, and if you notice, these are two bases that are same that have subtraction, so we can use a rule for that. Exactly. And then over on this side here, we're still left with 3x, got that nasty little log attached to it, and then plus x. We can simplify this. Log 7, 3 over 2, which is a half, minus 2 is equal to, okay, this piece here, we can common factor out the x.
Yeah.
So if we common factor out x, hi Trixie, x goes to the outside, and we're left with 3 log 7, 2. I mean, I could put the 3 back up there, and that becomes log 7, 8. Will that be helpful? I mean, a little bit. We'll leave it as is. The key here is x is now a single term.
Yeah.
This is perfect. Now that it's a single term, this can become division. It can go to the other side. And then we get log base 7, 3 over 2, minus 2, all divided by, I'll leave it, I'll put it back as an exponent. Log base 7, 2, actually 2 to the power of 3 is 8, so we'll just change that to 8 is equal to x. This is just simply putting into a calculator. Yeah, let's see if we can get a calculator up here. Let's Let's do Desmos Scientific. All right, let's see if we can put this all together. We got fraction that is, oh, it doesn't let me do base 7s on these, I don't think.
I have it.
Do you? Oh, awesome. You tell me what you get there in that case. I could do a change of base, but if you have a calculator that does base 7, that'll work out much nicer. Otherwise, I have to do a huge change of base formula, which just ends up being a lot of fractional algebra, which, I mean, is good to practice, but if your calculator does it, it's much easier that way. Could use Wolfram. Wolfram will do it. Negative 1.67, roughly?
Yeah.
1.677, let's say. Approximately this. So once you plug that into a calculator. But the toughest part of this question was essentially manipulating the algebra to get the x by itself. That was the hardest piece.
Yes.